Hi, this is Tonya. There is a second method of performing binary operations which is frequently useful. If, and only if, two tables have both row labels and column labels, then this method can be used. To use it, you enter the action turn on math using labels. Then, whenever two such tables are combined in a binary fashion, commonly labeled rows and columns are selected for each factor. The rows and columns for the right factor are then reordered, if necessary, to align them with the left. Finally, corresponding items are combined. For example, consider the following two tables. Now multiply them together. Clearly, only commonly labeled rows and columns were kept. An examination of the result shows that those on the right were rearranged to match the order of those on the left before the multiplication was done. This method is useful even if the only purpose is to align corresponding rows and columns before a mathematical operation is performed. Here is a possible additional use. Let's look at Table 3, which gives some hypothetical employee information. Suppose the salary of Sonia Caldwell is short by $3,000. Consider the following matrix we have called Cell 11 and add it to Table 3. We see that the labels have found the appropriate location and return the new salary. To replace the old salary in the original table, we simply do this merge. As an aside, we remark that the table Cell 11 could easily have been created by hand using the action Create Table, but the following two lines will create it automatically. The same technique can be used to modify a single row or column of a matrix. Adding and removing labels is trivially easy in Accelerate. To return to the default method of binary options, simply enter the action turn off math using labels. There is one case in which the corresponding labels method is always used no matter what has been selected, and that is the case where both factors are time series. This is because in financial work, it is almost always necessary to use common dates when comparing calculations. The following two tables are time series. We now add them together and we see the common rows and columns have again been kept. There is one additional case where neither method is used, and that is ordinary matrix multiplication. Two tables, considered as matrices, must satisfy the standard mathematical definition of product capability in order to be multiplied. This means the number of columns of the first matrix must equal the number of rows of the second. The labels, if any, are ignored. Here is an example. We create two small matrices having the correct size. Now we take the matrix product. Here is another simple example. We create this 2 by 2 matrix. Then we take its matrix inverse. We now multiply the two together and, as expected, get an identity matrix.